This is Miss Birmingham, and this is the lecture for Chapter 1, Introduction to Psychology for PSY 1012. Let's get started. Well, a great place to get started when we're talking about psychology is literally talking about what is psychology, or at least the definition of psychology. Now, there's a couple of key things to this definition. The first word is behavior. Now, notice that the definition doesn't say crazy people or how the mind works or studying the mind. We're very specific here because this is a science, and that's one of the first things I want to cover is what is science? And science is using facts to come to conclusions. Now, many people tend to think of psychology as something that comes from the gut. And what I always try to remind people is that there are two branches that look at behaviors. One is psychology, which is science, and one is philosophy. Now, philosophy is the unscientific, looking from our gut type of viewpoint of the world. So in philosophy, I might walk outside and I look down my street and I see that most of the street has red cars. And so I would theorize that people love red cars because I see a bunch of red cars out there. Now, psychology would say that's a bunch of hogwash because you have no proof of that. What you do see is some people who own red cars. But how do we know that most people like red cars? You're making this information or this conclusion based on a very small number of people. We'd have to go out and collect data. We'd have to go out and analyze things. We'd have to do some scientific study before we would agree that people like red cars most of all. So this is science. If you are going to be using things from your gut, that would be a philosophy class. So we do say that psychology is a science. Now the other part is that there is the professional side of psychology. We'll talk about that toward the end of this particular lecture. But it is the one that most people get the most viewpoints of or have seen the most exposure to up until now. But as far as we're concerned, the first thing we have to understand is that it is a study of behaviors. And there are two basic types of behaviors we tend to talk about: overt and covert behaviors. Now, overt behaviors are those ones that are viewable, like running, eating, jumping. I can see those behaviors. The other type of behaviors that we talk about are covert behaviors. Now, covert behaviors are, of course, things we can't see. So think about like covert operations. Those are hidden or sneaky. So if I'm thinking about eating, that's a covert behavior because you can't see me think. Watching TV. The watching of the TV is actually a covert behavior because watching occurs inside my brain. The other part of this definition, besides the word behaviors, is mental processes. And people often ask me, well, what's a mental process? Well, this is the actual functioning of the brain. This is the neurotransmitters. This is the electrical currents. We'll cover those in Chapter 2. But most mental processes are covert because we can't see those. So if you think about it, I can't see you thinking. I can see the wiring in your brain and I can see the electrical circuit going, but is that really thinking? I can't see your thoughts, your actual thoughts. So I'm dependent on these overt observations, how you're standing, the tone of your voice, the electrical current in your brain, to make decisions about the covert things that are going on. So we're always talking about overt and covert. Because we are talking about a science, we need to understand that we're looking at empirical evidence. And basically what we're trying to do is improve on that sort of common sense knowledge that we tend to talk about. And I hear common sense knowledge all the time on TV. Well, it must be this, or it must be that. The talking heads are always using that. But again, we are not using philosophy. We're not using common sense. We're going to be using scientific observations. Now, the other types of observations would be casual observations. So if I walk out and I see all those red cars, I made a casual observation. A casual observation may get me wondering about something, and which makes me then make a scientific observation. But casual observations are not scientific. So what is a scientific observation? Basically, this is information that we've collected through direct observation and measurement. Now, these two words are very important because if something is not observable, and it is not measurable, I cannot study it. And if you think about it, that makes sense. If I can't see it, how do I study it? If I can't measure it, how do I know if there's a change? So let's use a word like love. Love is kind of an interesting word because we all kind of know what love is, but what is love? And when I'm going to go study love, what love am I studying? Am I studying the love between two teenagers who've just met each other? Am I studying the love between two people who've been married for 50 years? Or am I studying the love between a parent and a child, or an owner and a pet? Those are all types of love. So we're going to have to be very clear on what our observation is. And if I can't define what I'm observing in some sort of measurable way, then I can't study it. And so most of our scientific observations are very systematic. They're very carefully planned. So if I'm going to be studying love, I'm going to have to define what love is. And so let's just say that I say it's love between a parent and a child. Well, now I need to make that measurable. How do I measure the love between a parent and a child? Well, I'm going to have to do something that's measurable. So maybe I measure how many times they use words that are approval words. So things like you're good, I'm proud of you, I'm so happy with you. I can measure that, can't I? I can measure the number of times I do that. I can measure how often they touch the child. I can measure how often their tone of voice goes up or their tone of voice goes down. Those are very systematic, carefully planned out. Now, in some cases, it may be something that we want to study that we can't quite systematically do. And so we're going to use more intersubjectivity with that. And basically, we're going to say it's got to be confirmed by more than one observation. So if I wanted to study, let's say, chimpanzees in the wild, I'm going to go out and I'm going to study them, but I'm probably going to have a couple of people making this observation at the same time. That way we can compare notes and see if we get the same sort of information. I might be at a certain angle and I don't see the facial expression of that gorilla, and somebody else is in a different position and they see that facial expression. So we're going to want to have basically more than one observation of this thing, which means that when we get to scientific studies, if I can't reproduce it, if I can't see this more than once occur, then we question whether or not the first time was actually accurate or was it an unusual phenomena. So we'll go back to our car one. If I'm going to scientific study whether or not people like red cars, I'm going to carefully plan out what percentage of the population I'm going to study, what percentage of that population would have to like red cars, what percentage of that population would actually own red cars. Be very carefully planned. Now, I do my study, and at the end, I come up with 30% of the population likes red cars. Just making that up off the top of my head. Well, the thing is that I've only studied that here in the United States. So if I'm saying that 30% of people like red cars, we're going to have to look outside the United States too. And so somebody over in Asia, let's say Japan, decides that, I don't know about those results. And so they go do the same study in Japan and they find that only 10% of the population likes red cars. So I've confirmed that the diagnosis that everybody likes red cars has been incorrectly identified because we couldn't make it happen again. Now, psychology does have some goals, and you are going to have to be able to memorize and regurgitate these goals. But more importantly, it's not just the definitions of these things that I want you to understand, it's the application. And you should also understand that when we talk about the exam, which most people are very concerned about the exam, my exams are far more application oriented than definition oriented. Of course, if you don't understand the definition, there's no way you're going to be able to identify the example. So let's look at the first goal of psychology. And the first one is description. If I can't describe something, I can't study it, can I? Now notice I underline the word classify. That's because classify is your key word. What I want to be able to do is to group things together. So if I can't make a group of something, then I can't describe it. As an example, we were just talking about love. And so one of the things I did was I classified different types of love. Love between two teenagers, love between two people who've been married for 50 years, love between a parent and child, love between an owner and a pet. I've named these classifications. Now I've got to get some measurable and observable behaviors also. And, when we talk about tone of voice and things like this, we might put those across all the different types of love when we talk about tone of voice. But what about proud, the word proud? How often are we going to use that to show a measurement of love between two teenagers and a love between two people who've been married for 50 years? That may not be something there. So we would say that maybe proud is going to be used when we talk about the love between a parent and a child. And I don't know if too many dog owners or cat owners look at their dog or pet and say, "I'm proud of you." Now they say good girl, good boy, good dog, good cat. So we might not use that there. So we use these different descriptions to be able to help us classify which behaviors belong in which group. If we can't classify it, we can't move on to the next step. And the next step of basically psychology, and I'm not certain why it's not moving. Let me try this. There we go. Had to use a different button, is understanding. When we talk about understanding, we're talking about the causes of behavior. So basically, what is the cause and effect? So in here, this is what we normally think of as psychology, you might say. A lot of people really work with the understanding. Why did somebody do this? What caused them to have that effect? So if we're going to be talking about something like a parent and a child, and we're talking about their love, what caused the parent to give the child praise? What was it the child did, or what was it that the parent has an expectation in doing? So if we can understand what the goals of that parent are and what the goals of behavior they want to see from that child, we now are beginning to get an understanding of that particular relationship. Next comes prediction. And basically, this is a forecast. So if I can describe what the love between a parent and a child is, and I understand what drives that behavior, then I can begin to predict when that behavior will occur. So let's again use the word proud. And we're talking about the love between a parent and a child. So we've described proud as a child doing something on their own without being told. That's the description of how somebody feels proud. Now, I understand, or I've learned, that this parent will tend to use the word proud when the child cleans up the room by themselves, that this seems to elicit this proud behavior. So I can predict that if the child could learn to clean up the room by themselves and perhaps even put something in the laundry without being told, that we're probably going to see the parent using the word proud or some word that's close to proud, because that's the feeling that they're having. So I can predict that we'll get a certain behavior based on that knowledge. Now, our last goal of psychology is control. Now, you have to be careful with this. When we say control, we are talking about the individual's ability to control or alter their own behavior, not a psychologist's ability to control you. I can't control you. The question is whether or not you can change a behavior you wish to. So in this case, again, we'll come back to that parent and child. And so if the child can understand that they're going to elicit this feeling from their parent by doing this, they may control their behavior and do this. But we may also want the parent to understand how they're using control. And perhaps the parent says, "I don't feel like I have a good connection with my child. I feel like my child is pulling away from me." And we talk about, well, does your child understand that you are proud of them? And so we can offer them opportunities to change that behavior. If they understand what drives them to use that word, and that's a word that the child needs to hear, then we can say, hey, is there anything else that can make you proud of your child besides them picking up their room by themselves? And here is how your child will react if you use this positive word toward them. So basically, these four behaviors or these four goals work together. If you think about it, we can't make predictions if we can't describe something, and we sure can't control something if we don't understand it. So each one of these works upon each other. Now, what we will find as we go out throughout this course, that not all psychologists are working on all of these at the same time. In fact, as an industrial psychologist, which is my primary field, and consumer psychology, prediction is the area that I tend to work in. Now, I did talk about the fact that I am this industrial organizational psychologist in class, and that part of my job is to hire people. So, if we think about it, when somebody comes in for a job interview, what I'm trying to do is to predict whether or not they are the correct candidate to fulfill that job. I am forecasting what their behavior will be like, and will that behavior fit with what my institution is looking for. So prediction is the primary area that I work under. Whereas if you think about a lot of the psychology you see on TV where there's all that talk, oh, I have such troubles, and I go see somebody, that is normally under control. Now, the one that we don't see a whole lot is description, primarily because it's exactly not a very fascinating thing to watch. But you might see that something on Animal Planet. Occasionally I watch a good show on Animal Planet that's rather scientific, and they are describing or classifying certain behavior patterns. Shark Week is a good example. They'll have certain shark shows on, and they talk about the behavior patterns of those sharks. So they're making descriptions of what's going on, and they're classifying the different behaviors of those sharks. Now, since this is a class about science, I am going to spend a lot of time on the research method. And basically what the research method is a scientific process for answering scientific questions. We have to develop a question, and then we look to see what the answer to that question is. And that's what a lot of this chapter 1 is dedicated to. So let's look at the scientific method. You'll find this chart in your book. Now, the first thing I want you to understand is that I do not expect you to memorize and regurgitate this chart, primarily because it's just a chart. Knowing the steps does not mean you understand the steps. But we do want to understand that the scientific method is basically this way of carefully collecting evidence and making descriptions and measurements and precise definitions with controlled observations and repeatable results. It's a very long definition of what scientific method is, but basically it's a formal process to test something. And what we want to test is information. Is this information fact or is this information fiction? So there are 6 basic elements here, and we're going to be looking at some of these elements a little bit closer, but we start with making an observation. If I can't observe something, remember, I can't study it. That's one of the 2 parts of empirical evidence. So let's say that I have been watching this small child since they've been born, and when the child goes into its first daycare center, it's maybe about 12 months old, I happen to notice that the child gets pushed around a little bit by the other 12-month-olds. And, it's not exactly bullied, but it's not exactly on the top of the heap either. And so I watch this child as it grows up. Now the child moves from the 12-month-old room to the 2-year-old room, and now there's no question this child is getting pushed around a little bit more than the other children. Toys are taken from it very easily. It wants a certain color. It's not going to get it because another child's going to come and take it. As this child moves on to VPK or voluntary pre-K, we do find that this child is beginning to get bullied. The bigger, meaner, tougher kids are beginning to push this child around. So the parents actually take this child because he's going to be entering kindergarten, and they move him to a new district, maybe where there aren't other people around. And we find that this child, when they enter kindergarten, again, they get bullied. There's something is going on here. And so in 2nd grade, they take this child and they move out of state. They get a new job somewhere. Child goes to a completely new school with a completely new culture with the expectation and hope that this child will not get bullied. But sure enough, it doesn't take very long and the child is bullied again. So I'm making some observations. I'm seeing a pattern, aren't I? And that's going to make me begin to develop a question. And so my question is maybe what's causing this child to be bullied? Well, I have to now begin to define a problem, and the problem is bullying. What makes somebody susceptible to being bullied? And that's what I would like to know. What makes them susceptible to being bullied? Now, what I'm going to be doing is proposing a hypothesis, and we'll cover that in a second. But the hypothesis is something that is not a question, it's actually a statement. And the reason it becomes important that a hypothesis is a statement is because I'm going to have to test this statement to see if it's true or false. I'll do that by gathering evidence, and we'll talk about evidence gathering also. This is what we talk about with experiments, it's correlations, it's natural observations. We're going to have a whole kinds of different ways that we gather evidence. And the whole point of gathering evidence is to test our statement. Then we're going to either retain or reject that hypothesis. Either we're going to say, yes, the hypothesis was accurate, or no, the hypothesis wasn't accurate, and we will move forward from there. Now we talk about published results. Now, publishing is kind of an interesting thing. And when we talk about published results, I must say, first of all, that this is for psychology in the medical fields. Now, the scientific process or scientific method that you see in front of you is used in all kinds of fields. If you are in culinary, you're basically going to do the same thing. You're going to be making new desserts or new foods, and you're going to start with some observation that people seem to like chili. And you're going to say, well, how can I use chili in a cake? And you're going to propose that I could use chili in a cake if I add chocolate and chili powder, and you're going to test a few recipes, and you're going to find out which recipe is the best, and you're going to move on from there. But in culinary, you're maybe not going to publish your results. You might want to keep that recipe for yourself, or you might put it in a cookbook. Same with computer science or even meteorology. If I want to discover a new metal, I'm still going to be going through the same process, except for this publishing results. But this is psychology class, and most of my students are going to go into some sort of medical field, and both of those fields, publishing is a requirement. Now, why do we publish? Well, we're not talking about publishing like in Time magazine or in some big Bubba's website. We are talking about publishing in what's called a peer-reviewed journal. And peer-reviewed journals are black and white, boring. There are no ads in them. They're things like the Journal of Nature, the Journal of Child Psychology. Probably the most famous is the Journal of American Medicine. Now, these journals are important because they are the watchdogs of society. Basically, if I want to publish my article, I'm going to go to one of these journals, and let's say the Journal of Child Psychology, and I'm going to say, hey, I've got this great article, I've done this wonderful research, I would like other people around the world to know about this because I think I have hit upon something very important. And so they would take this article, they would review this article, and they would be looking for things such as, did I do my statistics correctly? Was my research actually done correctly? Did I have enough people in my study? They would look at all these things and they would determine whether or not this was well done. If it was well done, then they will publish my article. If they want more information, they're actually going to send that article back to me. I'm going to sit there and take a look at it, and I'm going to turn around and have to give it back to them with some corrections. It might be that they want more information about my subjects. Maybe they want to see more statistical information. It doesn't really matter. What matters is that they are double checking that I've done good science. If they feel the science is good, then they will publish. So the first reason that we publish is because we want to be able to check the science, and that requires that peer-reviewed journal. Now, the second reason we publish is basically for communications. I mean, how are we going to find things out if there isn't some place to find these things or read these things? A great example is that there's this little area in the brain that if it is damaged, and it's called having a lesion on it, we find it changes the personality of this person. It tends to make them very interested in food, become sort of a foodie, you might want to say. Now, this was first discovered by a psychologist in, don't quote me on this, I think it was like Switzerland or Sweden. It began with an S somewhere. Swahili, not certain. But basically, he had a client who had gotten this injury and had had a head trauma. And as he recovered from this head trauma, his personality had changed. Now, what was unusual is that this person had been seeing a psychologist before the trauma. So the psychologist was able to understand that this change in personality occurred, and had looked at some of the studies that were done on his head and noticed he had this little lesion and in the area that did control taste and appetite. Well, he published his results. After they published their results, somebody else said, well, I had this client that had sort of this change in attitude, and they asked the client if they would go in for an MRI scan, and sure enough, that same person had a little lesion in the same spot, which led another person to go, hey, I have a client who did that, and they had some head trauma, and after the head trauma, they were very interested. In fact, they left the job that they were doing and they became a chef. And sure enough, guess what? A lesion in the same place. Well, you see, we would never have known that if the first person hadn't published. So it's very important in psychology and in medicine that we publish results. In fact, we would consider it to be unethical not to share that knowledge with the rest of the community. And magazines or journals such as the American Journal of Medicine are extremely important within the system of our healthcare. In fact, on the news, quite often you can hear them announcing some new breakthrough, and they'll say to you, as published tomorrow in the Journal of American Medicine or in JAMA, or published in Nature of America. There's so much that is done through science, and if we didn't have these peer-reviewed journals, we'd have no one double-checking these things. So published results are very important, but I do put the little sort of caveat that we're mostly are talking about things like the psychological fields and the medical fields. And those of you who are in other fields, such as our science fields of computers, our culinary fields, our criminal justice fields, you may or may not have to publish. But no matter what, let's say that we've done all this, we've published our results, and now we are what's called theory building. And the reason we call it theory building is that we probably can't answer the question in only one running of this experiment. So let me ask you, in your head, let's say that my hypothesis was that a person who is passive will be more likely to be bullied, because that's what I believe. I believe this child is a passive child, and because he's passive, he's going to be more susceptible to being bullied. And I've done my collection of my evidence. Now the question is was my hypothesis correct? Was I rejected or retaining that hypothesis? Well, the truth is I would reject that hypothesis. We have not found that being passive has made you more susceptible to being bullied. Passive does not always mean that you won't stand up for yourself. Passive just simply means that you tend not to want to fight, but they still will find other ways. In fact, many of our great leaders like Gandhi and Martin Luther King were both pacifists. They didn't do physical fighting. They found other ways to fight back, you might want to say. So I published my results. Now, from that one study alone, does that mean we understand bullying? Absolutely not. We're going to have to do more research to figure out why bullying occurs. Not only that, but I've only tested this one time. So remember I said very early on that we're going to have to test things 2 or 3 times to make sure the results are accurate. So we're going to have to go back all the way through this again. Now, remember, one of the steps was a proposed hypothesis. So we want to understand exactly what a hypothesis is. And it says it's a scientifically testable prediction outcome experiment, or basically an educated guess. And that's the big thing that we need to look for here, is the educated guess. So what is an educated guess? An educated guess is one in which what I've done is spent my time reviewing and looking at all the information that is out there. And I've looked at it through my naturalist observations. I've read research on it. I've done other studies I've seen on it. Basically, I'm not just going from my gut. I'm going from a spot of understanding. And so I've made some initial attempts to understand what's going on. And based on those initial attempts, I've made an educated guess. So keep remembering that a hypothesis is sort of an educated guess. So if that's a hypothesis, then what is a theory? Well, the thing about theories is the first thing is that we have to understand that it's based on facts, and it has to be proven through the scientific process. So basically, a theory is what's there after everything has gone through that scientific process. And at the very end, you notice we said theory building. So we have to be able to prove this. So for me, a theory is not a hypothesis. And one of the things that you have to understand is that a lot of times on TV, when you hear people talking, they're really spouting hypotheses. And I yell all the time when they say, well, I have a theory about why this person did this. And I go, no, you've got a hypothesis. You don't have a theory. The truth is that today the word theory is used in many different contexts, sort of like the word frozen. Do we mean to stop, or do we mean the process of taking something from water to ice? You know, it has a couple of different connotations. Well, same with theory. But in this class, when you read the word theory, it is something that has gone through the scientific process, something that has been proven, something that has become a fact. So don't go with the sort of the theory where we're just kind of making it up. That's more philosophy kind of theory. For us, a hypothesis is the educated guess, and a theory is something that has been proven through scientific fact or through the scientific process. Let's look a little bit closer at how we gather evidence to test the hypothesis. And the first one is experiments. Now, experiments are going to be the do-all and end-all for cause and effect. It's only experiments, and listen again, only experiments show a cause and effect relationship. So there's a lot of information about experiments in your textbook that we're going to talk here. It is one of our major topics for this particular lecture. And as such, we're going to go through some detail, and then we're going to go back and try to put it all together for you. So let's understand that there are three basic types of variables. And what is a variable? Well, a variable is any condition. I love how they use condition. But basically, it's anything that could change an outcome. So a variable can be weather, because the weather can change an outcome. A variable could be temperature. A temperature could change an outcome. Now, in science, we have basically three types of variable. And the first one is the independent variable. Now, there's generally only one independent variable in simple experiments. And we're mostly just going to be talking about simple experiments in this particular course. So the independent variable is easy to spot because it's the thing that changed. So when we talk about this room and this room, or this person, what is the one thing that changed? So the thing that changes is our independent variable. And we'll be going through some examples here in just a little bit. Let's get some more definitions. The next thing we have to look at is the dependent variable. Now the dependent variable is the outcome. They use this fancy word, demonstrates the effect of the independent variable have on the effector. Basically, it's a measurement. It is the outcome. It always has a number. So you are always looking for a number to find that dependent variable. The last type of variable we'll talk about is an extraneous variable. And these are things that have to remain the same, because if they don't remain the same, they could be the reason for the outcome. So let's talk about a plant. Let's say what I'm going to do is want to know if feeding my plant different amounts of fertilizer will result in different growth patterns. So I'm going to create a hypothesis. It's my educated guess from what I've seen in my research and what I've read. My educated guess is that if a plant gets basically fertilizer twice a week instead of once a week, that I'm going to see a better growth rate. So my independent variable is going to be how often a plant gets fed. So I've gone off to the store and I bought 20 ruby red tomato plants that were all 4 inches tall. They were little short things here when they started. I'm going to take all 20 ruby red tomato plants and I'm going to put them in the same greenhouse. Why? Because we have to control for these extraneous variables. They all would have to grow in the same place, wouldn't they? Because if they don't all grow in the same place, then maybe it's the environment that affected their outcome rather than how much fertilizer that they got. So I'm going to put them all in the same little greenhouse. And they're all going to get watered the same amount on the same day. Again, we need to make sure they get water, but we want to make sure that the water isn't what's going to affect how much they grow or don't grow. So half of my ruby red tomato plants are going to get fertilizer once a week, and half of my ruby red tomato plants are going to get fertilizer twice a week. So notice my independent variable is the amount of fertilizer, because some are going to be getting it once a week and some are going to get it twice a week. So there's a change in that variable. Now, some people might say, well, the fertilizer itself is the independent variable, but it can't be, because I'm studying how often they get fertilizer, not which type of fertilizer it is. So be careful that you look at exactly what the change is. In fact, I'd have to use the same type of fertilizer on all the plants, wouldn't I? Because if I use type X on one plant and type Y on the other, then that could be the reason for the difference in growth patterns. So the fertilizer is actually an extraneous variable that has to be kept the same in both experiments. Now, at the end of 6 weeks, what I'm going to do is measure how tall they got. I'm going to have a measurement. So I have some sort of number. So that means that how tall they got is going to be a dependent variable. The other thing I'm going to have measured is how much fruit they produced. How much? Again, it's a number. So that's a dependent variable. So I had two dependent variables, and that was the height of the plant and the number of fruit they produced. So we have an independent, dependent, and extraneous variable. So let me go through them again, and I'm going to throw a couple of experiments out there, and in your head see if you can answer the questions. So remember, what we're looking for in the independent variable is the thing that changes. The dependent variable, we're looking for the thing that is the outcome, a measurable outcome. Everything else is basically an extraneous variable. So let's say that I have a great little doggy, and my little doggy loves to run outside and run around the yard. Well, that was okay back in my old house, but I've moved to a new house. And now my problem is if my doggy runs outside, there's lots of cars out here. So I want to get my doggy back in the house the fastest I can. And what I need to determine is if peanut butter or chicken is going to motivate my dog to run home faster. So I'm going to create an experiment. I'm going to use my hallway, let's say, and I'm going to put my dog down, and I'm going to call my dog, and at the end of the other end of the hallway, there's going to be some peanut butter. And I'm going to time how long it takes for my dog to run down that hallway and get to the peanut butter. The next day, I'm going to take my dog at the same time of day. I'm going to put her in that hallway, and this time I'm going to put some chicken down at the end of the hallway, and I'm going to have my dog run. And I'm going to see how fast she runs for the chicken. Now, depending on which one she runs faster for, I'm going to assume that that's what she's more motivated to do. So the question is what was my independent variable? What was the thing that I changed between those two experimental runs? Well, if you said the type of food, peanut butter or chicken, you are correct. That was the independent variable. Everything else had to remain the same. So what was the dependent variable? What was the measurable outcome? If you said how long it takes for her to run that distance, then you're correct. That was the dependent variable. Remember, it had a number. It was the time. So what were some of the extraneous variables that I had to keep the same? Otherwise, that would be the reason that the dog had a difference in how fast it ran. Well, the hallway was one. Remember, I said I put her back in the same hallway. The time of day was another one that I mentioned. We're going to cover a lot more of these in class. You will see a couple of these on your test. So come prepared to see if you can figure out what the independent, the dependent, and extraneous variable is when we are in class. When we are running experiments, most of the time we're going to have some sort of subjects that we're running this on. And subjects can be animals or people. Both of them would be considered subjects. They may also be called participants at times. Now, the first group we're going to have is an experimental group. We're going to take these people here and we're going to divide them. I'll just divide it right here so we have a man and woman on each side. Half of these people are going to be experimented on. That means that we're going to be manipulating something on them. So they're going to be called the experimental group. Now the other group, these two people over here, are going to be the control group. We're not going to manipulate anything on them because we have to have something to measure them against. So let's say that what we'd like to test is whether or not alcohol affects your abilities. So these two people over here, they're the lucky ones. They're going to be getting some shots of tequila to drink. And these two people over here, they're going to be getting shots of water to drink. And let's say I've set this up that I've got some sort of bell that they're going to ring. Well, the first thing I'm going to do is have them put their hands down on the table before they've had anything to drink, and I'm going to say 1, 2, 3, hit the bell, and they're going to go ding and hit the bell. I'm going to measure how long it takes from them between when I say go and for them to hit the bell. Now in the beginning, hopefully my control group and my experimental group have used basically about the same amount of time to hit the bell. At this point, my experimental group hasn't had anything manipulated on them, so they should be basically the same. Now I'm going to give them each a shot of whatever their favorite drink is. And 5 minutes later, I'm going to say, let's do this again. 1, 2, 3, go, and ding. And my guess is that our two people over here, they're not going to be that much different from my little control group because it's only one shot. Let's say we've done this for a while now. We're up to shot 4. And now I'm going to say 1, 2, 3, hit the bell. Now remember, these guys have been drinking water, so their time hasn't really changed much from the very first running. These folks, they've been drinking alcohol over here, and we're going to begin to see that their time is slowing down. In fact, maybe they even missed the bell altogether. So why did we need these people in the first place? Well, how do we know that it was actually the alcohol and not the length of time that the experiment took that tended to change the ability to hit the bell? I mean, after all, if we've been doing this experiment for, let's say, 2 hours, maybe it's simply being tired. Well, both groups of people are tired, aren't they? So the control group will be showing the effects of tiredness too. Well, maybe it's the fact that I don't know, I have to be in this room. Well, both groups of people have been in that group. So we need the control group to be able to measure how these people are doing. How have they really been affected? By the way, in that experiment, can you identify what the independent variable was? What was the one thing that we changed between this group and that group? Well, it was the alcohol. Now, some people ask me, well, why are they getting shots of water? Why would they have to drink anything? Well, we'd want everything to be exactly the same, correct? I don't know about you, but after I've had some water or iced tea or whatever it is that you're drinking, I have to go use the bathroom after a little while. So we'd want to make sure it wasn't just the full bladder that may have made these people not perform well. After all, these people have had the same quantity of liquid. The difference is the type of liquid, and that would be alcohol. What was the dependent variable? The time it took to hit the bell. Remember, that was the measurable outcome. So what were some extraneous variables? Well, we put them in the same room. They were doing it at the same time of day. They were taking drinks at the same time. All of those things had to be the same. We even had sort of the same mix of people, men and women, because we might find that women work differently than men depending on their size. There were many things that we'd have to control for. But we need both groups in order for this experiment to be correct. If I did not have a control group, then I couldn't really understand what this difference truly was compared to those who didn't have alcohol. The other thing we have to talk about is random assignment. Now, this is very important. You must have an equal chance of being assigned to either group. So when these people came in originally to the experiment, probably what happened is that they had a bag, and in the bag there were marbles. And depending if you picked a white marble or a black marble would tell you which experiment you got to go to. Now, why is random assignment important? Well, if we don't have random assignment, we could stack the deck, you might want to say. So listen to this true experiment that was run by the Transcendental Meditation Society in California and see if you can understand what went wrong. The Transcendental Meditation Society of California wanted to show that meditation lowered blood pressure. Really good thing. So they put an ad out in the paper and they asked for some average LA people to come up and participate in this experiment. Now, there's nothing wrong with that. I mean, we need subjects to be in this experiment, and how else are you going to get them unless you ask for people? So some average LA people showed up to participate in this experiment, and they said, thank you very much for coming today. What we're going to do is take your blood pressure, and then we're going to ask you to go about your normal lives, and once a week we'd like you to come back, and we'd like to take your blood pressure each week. And they labeled this the control group. Now, there's nothing wrong with this. That's exactly what you want to do. You'd want to get what you started as. And we're not asking these people to do anything special, so hopefully we have enough people that we're going to see some variance. That is true with blood pressure, but we're going to just see everyday people. Remember, the Transcendental Meditation Society is going to want to show that meditation lowers blood pressure. So our control group is going off to live their everyday lives. Now, they get another group who comes in. Now, this group has all just joined the Transcendental Meditation Society. They're all brand new to this group. And they say, thank you so much for joining the Transcendental Meditation Society. Today, we're going to take you to go get your blood pressure taken. We'd like to see what your blood pressure is today. Then we're going to teach you to meditate. And we're going to ask you to meditate once a day. But over the next 6 weeks, we're going to ask you to come back on Monday, let's say, and we're going to be taking your blood pressure. And we're going to see if there's a change in your blood pressure over time, and we're going to measure that against a group who is not meditating. So this group is the experimental group, right? They're having one thing manipulated. They're going to start to meditate. They didn't meditate before. They're going to meditate now. Our control group is not meditating. So supposedly the difference between what the experimental group does and what the control group does as far as blood pressure is concerned should be because of the meditation, because they're both going to go live their lives. Here's the problem. Remember, my control group was average LA people. My experimental group were people who just joined the Transcendental Meditation Society. Do you think people who just joined the Transcendental Meditation Society, especially back in the 70s, represent average LA people? My guess is not. My guess is the average LA person, especially in the 70s, probably wasn't thinking about joining the Transcendental Meditation Society. In fact, the people who joined the Transcendental Meditation Society were already looking to improve their lives and looking to do something to help their lives be less stressful. So what we don't have is random assignment. And actually, this experiment was considered to be failed because we basically stacked the deck, you might want to say. What they did is they took people who were already looking to lower their blood pressure, who were looking to improve their lives, who were looking to improve everything about them, and they measured them against people who were just living their lives. It was a stacked deck. Now, you can use both groups of people. However, both groups had to have an equal chance of being put into either of the experimental or control group. So what we're basically saying is that we could have average LA people come up. They pull a marble out of a bag, and if they get the black one, they go into the experimental group. If they get the white one, they go into the control group. So we take some average LA people and we say, hey, we're going to teach you how to meditate. We're going to ask you to meditate once a day for 6 weeks, and we're going to measure you. If they do that, that's great. Then the experiment is using 2 equal groups. In fact, we can use all the Transcendental Meditation folks in this group too. Let's say I pull a white marble and I'm a member that just joined the Transcendental Meditation Society. That means I went into the control group. And in the control group, I'm told, hey, we want to thank you for joining the Transcendental Meditation Society, but we're going to have to wait 6 weeks before we teach you to meditate. We're going to ask you just to go live your life like you normally do, and we're going to be taking your measurements once a week, and we're going to be comparing it to people who are just learning how to meditate. That makes it a fair experiment. But before that, it wasn't fair because the groups were stacked. So we have to be very careful about random assignment. We can't stack the deck, you might want to say. The other thing we have to worry about in experiments is what we call research bias. Basically, the results of our research has to be because of the difference between our experimental and our control group. So the results, again, is our dependent variable. And it must be due to that independent variable. So the difference in blood pressure has to be because of meditation. The difference in growth of the plant has to be because of the amount of fertilizer. So one of the things we have to understand is that sometimes when somebody participates in a research, just the participation itself could bias the behavior of the person. The participant could be acting differently. So what happens if you feel like you're going to be getting a happy pill, but you're depressed? So you come in and I say, hi, thank you so much for participating. Group A, Group B there. Group A, hey, here, we're going to give you this happy pill and we want you to go off and live your life. And Group B, I'm sorry, you don't get the happy pill. We're just going to be measuring you to see how your depression changes over time. Well, I don't know about you, but if I was in Group B, I would probably be going out the door going, man, my life sucks so bad I didn't even get the happy pill. and I'm getting more depressed. Am I getting more depressed because I didn't get the pill, or am I getting more depressed because I think my life is not any good? And the other group, if I was in group A, I go, woohoo, life is looking up, man. I got a happy pill, going home with a happy pill. And now all of a sudden my behavior is changing. My outlook is changed. How do I know it's actually the medication that's made a change? So we have to be really careful about the fact that somebody's just personal behavior could change the outcome. So how do we control for that? The good old placebo. Now, placebo is a fake or something fake. Now, be very careful that people tend to say placebos are fake pills, but it could be a fake injection. It could be lots of different things. And so what's going to have is that we're going to have a placebo and we're going to have the actual test drug. The placebo would be given to the control group, and the test drug would be given to the experimental group. We'd want both of those people who were depressed going out with pills and thinking that they're going to be getting better because they got the happy pill. Now, because they think that they're going to be getting better, at first the placebo group may see an increase in a drug, a neurotransmitter called serotonin. Serotonin is the happy one that makes us feel good. So maybe at first when they walked away, they got a little increase in serotonin because they became happy, but the increase quickly disappeared because they really weren't getting happier. They just had a little blip, you might say, on the radar, and they go back to normal. Whereas the people who took the test drug, they got that little blip up of serotonin, but the drug produced more serotonin, and so they remained happier for a longer time. So that's how we would have the placebo. The placebo effect basically is the effect that somebody has because they believe something. So we take this pill and we think it's going to stimulate something. Now, the interesting thing about placebo is that it may be based on, as we say, suggestion and not the actual chemistry that's going on. And we've always heard about, the doctor gives out the placebo to the patient who just feels like they have to have a drug to be able to be cured. One of our big problems actually with this right now is people come in and they've got like a flu virus and they're given antibiotics because they feel like they have to have something to help them fight the flu. The problem is that antibiotics are for bacteria and it won't do anything for the virus that you have except for to make you perhaps antibiotic resistance. So placebos are given out a lot more than you think. In a experiment, we really need to use placebos if we really want to see the effects of a drug because of the psychological effects that somebody might have. So we have to control for these things that occur. And one of the big things that we're going to talk a lot about throughout this course is something called a self-fulfilling prophecy. This is sort of a definition, but basically what a self-fulfilling prophecy is when you believe something is going to occur, you tend to make it happen. So you make a prophecy about yourself and you make it happen. Let's say that I believe in astrology and it says today I'm going to meet somebody new. Well, if I believe in astrology, then I might actually behave slightly differently today because I believe I'm going to meet somebody new. So I go to the gas station and today I happen to be a little bit more chatty than normal and I look up at the sky and I say, oh my gosh, look at that. The 3 o'clock rain is coming a little early. It's going to be 2 o'clock rain today. And the little person across from me goes, yeah, I was stuck out yesterday in the rain and I thought it was going to rain at 3, but it was 2:30 and I got soaked. Oh, I got soaked also. Can you believe it? Over there by the Kmart. Oh, I was by Kmart too. Did you know Kmart's closing? No, I didn't know Kmart's closing. And then all of a sudden you begin to talk a little bit more and you find out that you live close to each other and you know all these things. And you walk away going, oh, I was supposed to meet someone new today and I just met somebody new. Well, normally do you chat up at a gas station? No, normally people are pretty quiet. But you changed your behavior because you believed you were going to meet somebody. And how unusual would it be to meet somebody who lives close to you? Not too unusual. How unusual it would be for somebody who, you meet might know some cutting news. Not too unusual. So what happened is that you changed your behavior. You believed something was going to happen, and because you believed it, you fulfilled that prophecy. So placebos work the same way. If I believe I'm going to get happy because I got this happy pill, then I may actually see a physical change in serotonin or attitude, and we have this change. So to control for that, we're going to have something called a single blind experiment. Now in a single blind experiment, what's going to happen is that my subjects aren't going to know whether or not they get the real treatment or the placebo. Because if you knew you were getting a placebo, then you might walk out all sad. Wah, wah, I didn't even get the real pill. I'm so unhappy. Life sucks. I'm going to be depressed forever. So I need to make sure that neither one of you knows that you've got the fake pill. The problem with that, though, is that I know one of you's got the fake pill. Here I am, I'm the experimenter, and I look at subject A and subject B, and I know subject B got the fake pill. Could it be possible that I treat them differently now because I know this? And because of the way I treat them, we now have an extraneous variable. I'm talking more to subject A than I'm talking to number B. I check up on number A a little more than I check up on B. B begins to realize something's wrong. I'm not getting as much attention. And maybe after a little while, they begin to realize they have the placebo. So I've screwed up my experiment because I know who has which pill. So to overcome that, we're going to have something called a double-blind experiment. Now, in a double-blind experiment, both the researcher and the subject doesn't know who's getting what. Now, how can that work if we're both blinded here? Well, how that works is basically I got a handy-dandy assistant somewhere over here. I should have drawn a little handy-dandy assistant over here. And the handy-dandy assistant is going to be the one who's going to create all the pill bottles or whatever it is. That handy-dandy assistant's going to give me the pill tray. And I look down the pill tray, they all look the same, and it just simply says A, B, C, D. I don't know who has what. So when I give them over here to my patient is going to be just equally have the same chance of having the placebo as the fake pill. As such, I am going to probably treat them all equally because I won't know who's got what. In fact, I don't even get to know who has what until not only is the experiment over, but all the data has been crunched. So I begin to crunch my data and I go, hey, look at that. Subject A and subject C and subject D, they all had a decrease in serotonin, but subject E, F, K, and L had an increase in serotonin. And as it turns out, those are the subjects who got the pill. So I see that my pill really did increase serotonin. Now, the other reason you need to know about single and double-blind experiments is that in the United States, double-blind experiments are required before a drug goes to market with the FDA. So you will often hear them asking for participants to participate in an experiment. And they can't tell you whether or not you've got the placebo or the real drug. This can be somewhat dangerous for some people who may have life-threatening cancers and they really need this drug. But the truth is that we have to do a double-blind experiment. If you read some of the brochures that you get about your drugs, they'll talk about single-blind and double-blind experiments. So double-blind is considered to be the most significantly accurate type of experiment that's out there. Now, sometimes we can't do an experiment. It's just simply either unethical or not able to, or just doing the experiment itself could change someone's behavior. So we might do naturalistic observations, and probably the most famous one is Jane Goodall, who studied these chimpanzees. And basically what we're doing is we're observing behavior in a natural setting. If you think about it, if Jane Goodall took these chimpanzees and put them in a lab, we're not going to see their natural behaviors. As a consumer psychologist, I spend a lot of time in naturalistic behavior. I want to see how you actually shop. And what you say you shop like and how you actually shop are two different things, and we prove it over and over and over again. So we use naturalistic observation to see how you do this. But there are some limitations to naturalistic observation. The first one is the observer effect. Basically, if you know you're being watched, you might change your behavior. You say, no, I won't. Well, yes, you do. You always know when your boss is watching you, a week or two before your evaluations. And sure enough, that week or two before your evaluations, you make sure you're on work on time. You come back from lunch maybe a few minutes early. You say a few extra hellos, goodbyes to customers. You're just a little bit more charming than normal. Why? Because you know that your boss is watching you at this time. So we have to make sure that the people don't know they're being watched, and there are many different ways to do this. Now, in the old days, we'd have to use hidden blinds and things like this. Today, we use everything from monitors to GPS tracking systems. There's all kinds of things that we do to help do that. Observer bias basically says that we only see what we want to see, or we're not exactly keeping really good records. So let's say I'm watching people shop. Now, the truth is I should roll a dice, and that dice says 6. I should take the 6th person who walks in who's over 18 and watch them shop. But number 5, well, he's kind of cute, so I think I'll watch him instead. Yeah, well, now I've just biased myself because I wasn't just taking a random number. Or maybe Jane Goodall only wrote down the things she wanted to see rather than watching all the behaviors. She wanted to see group socialization, so she only wrote that down. She didn't write about inner fighting. She did write about inner fighting because she wasn't biased. She wrote about everything that she observed. So we have to be careful that we only write and observe and write about what we observe rather than what we want to see. Now, the last one is kind of fun. It's anthropomorphic fallacy, and you shall never have to say that, nor will you have to spell it. But basically what this is giving animals human emotions. Now, we're not saying animals don't have emotions. Understand that. Animals have emotions. What we don't know is if they have human emotions. And we have to be really careful that we can't say that their behaviors are based on human emotion. That's my human emotion. So when I open the door and my doggie comes running up and wagging her tail, and I say, oh, she's so happy to see me. How do I know she's happy? Does she experience happy? Or is she joyful? Or is she excited? Or is she hungry? I don't know, do I? And I can't ask her because I can't speak dog. I do know she's showing an emotion that seems to be an excited emotion of some sort, but I'm not exactly certain if it's happy. And we have to be really careful about that because we tend to describe a lot of animal behaviors based on human emotions. I really love is when people describe insect emotions, and yet insects don't have an emotional center in their brain. So all of a sudden we hear ants being hostile and aggressive and mean and spiteful. It's like, I don't know if ants have even emotions or not. So if we're doing naturalistic observation, we have to be very careful that we're not describing them based on human emotions. What I can describe is the overt behavior. Remember the behavior I saw. One animal groomed the other animal. That animal groomed this animal. These two animals, after grooming, spent more time together. This animal then got food for that animal. I can describe all that, but I can't say that one thing was motivated by the other as far as a human emotion is concerned. That's where we have to be careful because we want to make sure we're not giving them emotions that they don't have or the incorrect emotions. Correlation studies are something I always like to cover. Now, many of you are going to go on into coursework where you have to understand what correlations are. So, especially those of you in the allied health, in the criminal justice fields, correlations are something that you'll talk a lot about. And a correlation is basically looking at how much does one thing cause something else to occur. Basically, is there a relationship between these two things? Now, it's really important. Right down here in red, really big. Correlations do not prove causation. It only shows a relationship. What it's going to say is that we're going to have two variables here. And the question is does one variable cause the other variable to change? No, it's going to show that there's some sort of relationship, but it doesn't mean that one thing causes the next to occur. So let's look at this first one. We're going to look at shoe size and GPA. And GPA goes up to a 4.0, and here's our little shoe sizes over here. So I go around the class, I ask for everybody's shoe size, and I look at what their GPA is, and basically when I plot it out, this is what I get. So I have some student who's got a size 4 shoe, and they've got a 1 GPA, and I put a dot here. I've got another student who's got a size, let's say 8 shoe, and they've got about a 3.5, 3.5 GPA. I put a point here. But if we look at this, there's no pattern to this, is there? So we would say there's no relationship. Your shoe size does not predict what your GPA is going to be, nor does your GPA predict what your shoe size is going to be. Well, this time let's look at how many hours you study per week. Does the amount of studying affect or have any relationship to your GPA? And when studies are done, we see something that looks like this. We kind of see that the more hours you study, the higher you get. Now you notice this little red guy just popped up over here. Now the red guy, he's kind of important because he is part of our study, but here's a pattern. Isn't it? It does look like the more hours I study, the higher my GPA goes. And yet this guy over here, he studied for less than 4 hours and he's got a 4.0. He actually has a name. He's called an outlier. And sometimes we have outliers in data. Now the question is can I ignore this outlier? Because after all, he doesn't seem to fit the pattern of everybody else. And the answer is no. I can't. He's still one of my subjects. And we may dislike this person because they don't have to study and get a 4.0, but we can't dismiss them. But at the same point, if I keep them in my data, it could skew or basically kind of give a false information of my data. So as an example, let's say I was trying to find out what the average income of a Kaiser Melbourne campus student was. And just as I'm doing this data, Bill Gates enrolls. Well, Bill Gates makes so much money that if I was to be looking at the average income of the students here in Kaiser University, Melbourne campus, he would inflate it, wouldn't he? He would make it more than actually what the average student does. But can I say, well, we're not going to use him because he's not, he's screwing up my data? The answer is no. We've still got to put him in there. What you may see occasionally when you're reading about research is you may see information with and without outliers. So basically what I do is I publish this piece of information and I say, I believe I have an outlier, somebody who's making my data not look correct. So here's the data with that person in there. And now here's that data with the outlier not in there. Then it's the reader's decision whether or not the outlier has made a dramatic effect on the outcome of the study. So did Bill Gates being enrolled in here dramatically affect the average income of the student? And the reader gets to make the decision, but I, as a good scientist, have to include everybody, including my little outlier right there. Now, you quite often have outliers in medicine. We don't know why one person suddenly gets better or doesn't get better when most people normally do. So outliers are kind of important. But in this case, basically what the science tends to be showing us is that the more hours I study per week, the higher my GPA. Well, let's look at the other way. Suppose we spent time to look at how viewing TV affects GPA. And studies have shown basically this pattern, that as I spend more time watching TV, I have a lower GPA, but if I spend less time watching TV, I tend to have a higher GPA. And there's our outlier. Instead of studying, they're watching TV all the time. So now the question is, did TV watching lower my GPA? Because over here we said the hours studying increased my GPA. So would that mean that watching TV lowered my GPA? Well, the answer is maybe not. Remember, we're just looking at the relationship between these two things. So my question would be well, why are you watching TV instead of studying? Maybe TV is just a symptom of other things. Maybe you find the subject boring. Maybe you're sick. I don't know about you, but when I'm sick, I veg out on the couch and watch TV. Maybe I'm stressed. The truth is, if you didn't have TV, you would find something else to do, wouldn't you, if you were sick or stressed or bored with the subject? But aren't those really the reason the GPA went down? The TV is simply a symptom of those things. So the correlation doesn't prove the causation, but it shows there's some relationship that if we see somebody who's watching a lot of TV per day and they're not studying, the question is why aren't they studying? Well, if that's true, then does that mean that studying does not cause the GPA to go up? Well, what we're saying is that there's some sort of a relationship between studying and GPA, but we also know there's a lot of people who are pretty smart who do not have high GPAs. We also know there are people who study a lot who still don't have high GPAs. One of the things that's kind of interesting is that, yes, studying does make a difference, but how well you study, how good is your studying? Just because I sat there and said I studied for 2 hours doesn't mean I really studied for 2 hours. And there may be other things that are driving my GPA to go up. Maybe it's motivation. For many people who take this course, you may be working in a company where, depending on the grade you get, will depend on how much they pay you back. Some companies will say, look, if you get an A in a class, I'll pay you 100%. You get a B, you get 75%. You get a C, I'll pay for half that course. Well, people get a lot more motivated about getting higher GPAs, don't they? So what we're going to find is that those type of things also affect GPA. So we're going to be looking at how one thing is related to another, but it doesn't mean that one thing actually makes the other one occur. Now, there are many different ways in which we can collect data. Case studies is one of the ones that's pretty famous. Basically, sometimes you're going to have a case in which you cannot do something. I can't stab somebody in the head just to see what's going to happen with that brain injury. I can't go rape somebody just to see what their reaction is going to be. But unfortunately, these things do occur. And because these do occur, it does give me an opportunity to study what goes on. So we talked about the gentleman who got a lesion in their head and how that study helped us begin to understand that that area of the brain seems to be connected to emotional connection or a connection with food, you might want to say. If it wasn't for case studies, we wouldn't understand what's going on. Now, surveys are something that's done quite a lot. In fact, you're going to be doing a survey in this class. And basically, it's an opportunity for us to get a large amount of information. I use a lot of surveys in consumer behavior. I'd like to know what your attitudes or beliefs are towards something. I will do a lot of surveys. One of the subsets of that is internet surveys, and a lot of you have taken an internet survey. The biggest reason for those is that they're pretty low cost. They can reach a lot of people, but there's still a lot of iffiness about internet surveys. You know, how many people actually answer? Are they of a specific age, specific income? We do find a tendency toward one type of person who does internet surveys. We also will see sometimes natural clinical testing. Again, we want to look at something that may occur that we couldn't really do in real life, such as an accident. Or a great example is after the earthquake or hurricanes, we might go in and look at some psychological information that's occurring there. And that gives us a lot of psychological data and helps us in the future. The last thing we're going to cover for this chapter is, the different kinds of jobs, you might want to say, in psychology. Now, what I do believe is that there's an enormous amount of different jobs in psychology, and I'm not expecting you to know all the different jobs, but I do want you to be able to understand the 4 that we're going to cover here. And yes, it's going to be on the test. You need to understand the differences between these 4. And this is just so you have some basic knowledge for yourself when you're out in the real world. The first big job is out there is psychiatrist. Now, a psychiatrist, you can always spot them because they have a medical degree. They are a physician. They are a doctor. And they specialize in treating mental disorders. So they went through and they got their MD degree, but instead of studying the heart like a cardiologist does, they study the brain. And they normally are dealing with people who only have mental disorders, like schizophrenia or bipolar. We have to remember that a lot of the things we talk about in psychology are not mental disorders. Schizophrenia is because there's something wrong with the brain. Clinical depression is there's something wrong with the brain. But being raped isn't a mental disorder. It is an event that occurred to you that caused you anxiety and harm, but it isn't a mental disorder. So not everything we talk about in psychology might need a psychiatrist. Now, the other big thing about psychiatrists is that they give medication. They're the only ones who can prescribe pills. So just because I was raped doesn't mean that I need to take antidepressants or have other types of medication. If I don't need those kind of things, there's a good chance I'm not going to see a psychiatrist, because a psychiatrist is only going to deal with mental disorders. And they can or can't give medication, but most of the time they do deal with medication. A psychologist, on the other hand, is what I am. And a psychologist will have either a master's or a doctorate degree. In my case, I'm at the master's level because I don't see patients. Not all psychologists deal with patients. In your book, as you scan through chapter 1, you saw a list of many different types of psychologists. There are human factor psychologists, which is a fascinating area. Those people who go into human factor psychologists actually have to have an undergraduate degree in either computer science or engineering, because their complete study is about how humans interact with machines. And that knowledge is kind of interesting, and that every computer that you use has had a human factor psychologist deal with it. Car designers, half of them are human factor psychologists. I need to understand how to develop the machines, but I also need to understand that relationship between machines and people. In fact, if you've noticed lately, that kind of yellowy green color is being used a lot on signage, and it's a human factor psychologist who began to discover we can see those miles ahead of the traditional colors that we've had before. Psychologists also may deal in fields like me, which is consumer psychology. Again, I don't deal with patients. I want to know what you buy and how can I talk you into buying more of it. You have school psychologists. You have gender psychologists who are studying the differences between men and women. What is actually biologically different and what is psychologically different. So it's a huge area of specialized knowledge, but we don't give out drugs and we haven't gone through medical school. Now, some psychologists need to be licensed in order to deal with patients, but only about 30 to 40% of us work with patients, which means a majority of us, over 60% of us, never deal with a patient. So psychology is a very large field. The psychiatric social worker is one that I always bring forward because a lot of times when I talk to people and they want to go into psychology, are you interested in psychology? What they don't realize is that it takes an enormous amount of time till you get to the point where you can deal with people, where you're actually dealing with patients if you want to do that route. You're talking about 4 years to get your regular bachelor's degree, and then you're talking about 4 to 5 years of doctoral work, and then a couple of years as a practicum. So you're talking about 10 to 12 years before you can deal with patients. And when I really talk to a lot of people, what I realize is what they really want to do is help those people who've had traumas in their life, such as the rape victim, such as the person who has an Alzheimer's parent, the juvenile delinquent, the drug addict. And what's interesting is that for many of these people, it's a psychiatric social worker who's really going to be the person who can help them. And incest victims, psychiatric social workers quite often are some of the best people to work with. Basically, they have a master's of social work, but they also begin to learn psychological principles. And if you think about it, somebody who's been raped not only has to deal with the anxiety that they're dealing themselves, but they also need to deal with the social aspects of this work. Somebody who's going to be adopting a child, a psychiatric social worker is generally the person who's going to deal with them. And this requires a lot less education because we're not usually dealing with people with mental illness. If you do find that you're dealing with someone with mental illness, you might be referring them on to a psychiatrist anyway. So think about that. If you're really interested in psychology, it is a field to look into. It requires 2 more years beyond your bachelor's work, and there are lots of jobs in it. Most hospitals have a psychiatric social worker. Most HRS departments have psychiatric social workers. It is a heavily I want to say demanded, but a much easier way to find a job as far as that is concerned. The last one I talk about is counselor, and I'm very careful about this word because a counselor has a huge degree of different things it can be. Basically, a counselor is someone they are trying to help you to solve some sort of problem. School, marriage, drugs. But the thing is that they may or may not have a degree. In fact, some of the best alcohol counselors I've ever met are people who actually were alcoholics themselves. They don't have any formal training, but they understand totally what it is to have that addiction. So be careful about counselors. They may or may not have degrees. That doesn't mean that they can't still be helpful, but understand that they are somebody who may have more real life experience than they've had actual training. So if I'm talking about somebody with schizophrenia, I probably want to go see a psychiatrist or a psychologist at least. If I'm talking about somebody who has drug abuse, I might want to see a psychiatric social worker and maybe a counselor at the same time. We may also want to see a psychiatrist to see if there's something that's gone wacky with our brain chemistry and they can help us with it. You want to make sure you see the right type of person depending on what the issue is. Just like going to a regular doctor, you wouldn't want to go to a cardiologist if you have a broken leg. You'd want to go to the orthopedic. So I always say to people, you want to do just a little bit of research about what type of person you might be best for you to get some help if you determine that you need some sort of help with a psychological problem. And yes, you got to know the difference between them for the test. Well, that ends this first lecture. I hope you enjoyed it. We're going to have several more as we go along, and I will see you in class. Please remember you can email me any questions you have, and I hope that this helped you. Bye.